Hi, Mr. Green here. I'm here to take you through another lesson of the electricity topic of the AQA Physics Combined Science GCSE. Learning objective today is explaining how to calculate electrical power, so please pause the video and write that down as your title. Okay, start as we always do with some retrieval practice. Pause the video whilst you attempt those questions. Okay, question 1. What's meant by useful energy? Well, useful energy is energy transferred by a machine in a useful way. For example, a motor produces movement. That would be what we want it to do. Question 2. What's Ohm's Law? Ohm's Law is potential difference equals current times resistance, or V equals IR. Question 3. The definition of current would be the rate of flow of charge. So those electrons that are moving to carry the current, how quickly are they flowing? Question 4, what's the unit of resistance? Resistance is measured in ohms with the symbol, the Greek letter omega. And finally, number 5, what's the unit of charge? Charge is measured in coulombs, which has the symbol C. Okay, our learning outcomes today are number 1 to define what power is, and question 2 to calculate the power of an electrical appliance given the potential difference and the current. Okay, so watts is our first title. What is a watt? We know that electrical appliances, we sometimes read on there, it's got so many watts. There's a 60 watt bulb there. What this means, 1 watt means 1 joule of energy is used every single second. So a 60 watt bulb would use 60 joules in a second. So you could from that easily work out if you left that bulb on for 10 minutes, how much energy would you have? If you left it on for 10 seconds, how much energy would be used? If you know 60 joules are used per second, you just multiply that by the time taken and you get the energy. So power is the amount of energy used per second measured in watts. To calculate the power, as it's a rate, it's dividing the energy by the time. So power in watts equals energy in joules divided by time in seconds. Quick question, a light bulb's on for 1 hour and uses 144,000 joules of energy. What's its power rating? Pause the video whilst you attempt that question. Okay, so watts equals joules per second. So 1 watt is 1 joule per second. So we want that time in seconds. So we need to work it out for an hour. We know there's 60 minutes in an hour, 60 seconds in a minute. So 60 times 60 gives us 3,600 seconds. That's our time. Our energy is 144,000. Divide that by 3,600. We get a power of 40 watts. Okay. Another question here, I've got 2 light bulbs there, a 40 watt bulb and a 20 watt bulb. 40 watt bulb is left on for 2 hours and the compact fluorescent bulb at 20 watts is left on for 2.5 hours. How much energy is transferred in each case? Pause the video whilst you answer that. Okay, so for the first one, 2 hours is 120 minutes, so 120 times 60 gives us 7,200 seconds. Power is energy divided by time, so to get the energy it would be power times time, so that's 40 times 7,200, 288,000 joules. For the compact fluorescent light bulb we'd have to do a similar equation first, working out the number of seconds in 2.5 hours, so in 2.5 hours there are 150 minutes, which is 2.5 hours, times that by 60 seconds gives us 9,000 seconds. Again, power is energy over time, so rearrange that. Energy is power times time. 20 times 9,000 gives us 180,000 joules. Try this one again. P equals IV. Power equals current times voltage. So, as well as it being energy divided by time, we can use this equation when we're working out electrical power. If we know the current and we know the voltage, we can work out the power. Power in watts, current in amps, potential difference in volts. So using that equation, calculate the power of a heater if it uses the 230 volt main supply and a current of 2 amps. Okay, so we've got our equation there. P equals I times V. I is 2 amps, V is 230, so it's 230 times 2, giving us 460 watts. Another example here, filament bulb draws a current of 6 amps from a 24 volt battery. What power supplied? Again, pause the video and answer that question. So we know our current is 6, our voltage is 24, our power we don't know, but we know that power is current times voltage. So 6 times 24 giving us 144 watts. Okay, got 5 questions for you here to attempt. So if we know power equals voltage times current, attempt those. Please pause the video whilst you attempt those 5 questions. Okay, so first one. Voltage is 6, current is 2. That's 6 times 2 giving us 12 watts. Number 2, 4 times 3 gives us 12 watts. Number 3, 10 times 2 gives us 20 watts. Number 4, 2.5 times 5 gives us 12.5 watts. And number 5, 12 times 0.6 gives us 7.2 watts. Okay, calculate the power supplied to each one if voltage is 230 volts. Remember, in each case, power equals current times voltage, so you only need the value of current from that. So pause the video whilst you work out the power of each one. Okay, so the kettle, 2070 watts. The vacuum cleaner, 1380 watts. The dishwasher, 2070 watts. The heater, 2070 watts. The fridge freezer, 414 watts. And the cooker, 3220 watts. Fuse ratings. So, what fuses do is they protect our electrical appliances from current that's too high going in there. So if you've got something that works at, say, 4 amps, if you put a 3 amp fuse in there, not enough energy would get into there. If you put a 5 amp fuse in there, enough current would get into there. So we've got this statement here. I'm sick of having to change different fuses in my appliances. I'm just going to put a 13 amp fuse in all my things so they keep working. Is that a good idea or not? And discuss the hazards in doing that. Pause the video and write down a few things that you think from that. Okay, so as I said, the fuse is there to protect the appliance from power surges that are too large. So if you've got an appliance that, say, only works with a current of 1 amp and you put a 13 amp fuse in there, any sort of energy surge, it will allow anything up to 13 amps in there. Anything that doesn't work at around 13 amps or above, sorry, not above, 13 amps, around that, it's going to blow, it's going to have too much energy in there. Now for each one of these, work out which fuse should be used for each appliance. What you're going to work out from these is the current, and then tell me which of those 3 fuses, 3 amps, 5 amps or 13 amp fuse would you use. Pause the video whilst you attempt that. Okay, so number 1, we need a 3 amp fuse. Number 2, a 3 amp fuse. Number 3, a 5 amp fuse. And number 4, a 13 amp fuse. You get that answer by calculating the current. Remember, power equals current times voltage, so power over voltage gives you current. Whichever's closest to that one, you don't want to go for one that's too high, but you definitely don't want one that's below it, because then you wouldn't get enough current. Okay, quick progress check. Pause the video whilst you attempt each of those questions. Restart when you would like the answers. Okay, question 1. Average power output of the construction worker would be 208 watts. Motor with a power rating of 1000 watts means it converts 1000 joules of energy per second. Convert these to kilowatts. So 1000 watts will be 1 kilowatt. Then got 0.5 kilowatts, 7.5 kilowatts, 0.001 kilowatts, and 0.1 kilowatts. To convert it to kilowatts, you just divide by 1000. Question 4a. The power of an 8 amp heater using mains electricity. This will come up in your exam a lot. They won't tell you what the voltage is, but if it's mains, you should know it's 230 volts. So that would be 230 times 8, giving us 1840. What fuse would be suitable for that heater? Well, it needs 8 amps. So if you fitted it with a 5 amp fuse, anything above 5, it wouldn't let it through. So you'd need a 13 amp fuse for that one. Calculate the power for each device. So the laptop would have a power of 76 watts, the kettle 2300 watts, and the smartphone 12 watts. So we've got another equation that we need to look at now. So if we remember, what's Ohm's law? Ohm's law is V equals IR, and the equation for power is P equals VI. So what if we combine those together? What if we rearrange it to make the same one the subject, so in this case I, and we put them together? We get P equals I times IR, which equals I squared R, which gives us our new equation. P equals I squared R. Power equals current squared times resistance. So with that in mind, calculate the power of an electrical device using a current of 10 amps and a resistance of 12 ohms. Pause the video whilst you try that one. Okay, so in this case, power equals 10 squared times 2. 10 squared is 100. 100 times 12 gives us 1,200 watts. Okay, next one. Calculate the resistance of a device that has a power rating of 1,000 watts and a current of 5. You need to rearrange the equation for this. So if P equals I squared R, you need to move I squared onto the other side. P over I squared equals R. So R squared is 5 squared. That would be 25. 1,000 divided by 25 gives us 40 ohms. Okay, so a load of questions there on that. Pause the video whilst you attempt those 9 questions. Restart when you'd like the answers. Okay, so question 1A. Current is 10 amp, resistance is 12. Give us an answer there of 1,200 watts. Question 2, 100 milliamps. We need to convert that to amps, so that would become 0.1 amps. Square that and times it by 3, which is the resistance, gives us 0.03 watts. Final one there, current is 50 amps, resistance is 3 kilo ohms. 3 kilo ohms is 3,000 ohms, so we need to convert that as well. 50 squared times 3,000 gives us 7.5 million watts. Second one, calculate resistance if current is 10 and power is 15. You need to rearrange our equation. So V equals I squared R, so R equals P over I squared. 15 over 15 squared gives us 0.07. Second one gives us 347, again 50 kilowatts, change it to watts. And finally, power is 12 milliwatts, convert that to watts, 0.012 squared, giving us resistance of 83,333 ohms. And the last one, calculate current if power is 60 watts and resistance is 15. You need to rearrange the equation. P equals I squared R, so I is the square root of power divided by resistance. That gives us a resistance of 2 ohms. For the second one, the resistance is 2.58 ohms. And the third one, 0.04 ohms. Okay, to finish off, we've got a past paper examination question, so please read through that, pause the video whilst you answer those questions, restart when you'd like the answers. Okay, question 1. Why is the component labelled J included in the circuit? Well, J is a variable resistor. If we make the resistance of J really high, we increase the voltage through J, which will reduce the voltage through the bulb. And if we make the resistance of J low, that will increase the voltage through the bulb. So we can adjust that to get a range of voltage values or a range of PD values. Question 2. The resistance of the bulb increases as the potential difference across the bulb increases. Why is that? Well, what happens to a bulb when it gets current going through it? It is just a wire, so the wire will get hotter. Question 3. The bulb's at full brightness when the potential difference across the bulb is 12 volts. The current through the bulb is 3 amps. What's the power? Well, we know that power equals current times voltage. So that would be 36. But to get the full answer, make sure you include watts. You include the value of watts. That's the unit. Finally, an electric drill draws a current of 2 amps and a 230 volt mains electricity supply. Use the equation to calculate the power of the drill. Pause the video whilst you do that. Okay, that's simple. Power's current times potential difference. That's 2 times 230, giving us a power of 460 watts. Hope this video was useful for you all. Lots of videos available on our YouTube website to review. I hope you really found this useful. Speak to you soon. Goodbye.